Yucca Mountain, Political Science or Scientifically Sound by Group B, Alan Deshler, Spencer Dyson, and Dale Romack. Today, I will be discussing the science used at Yucca Mountain and the science of some of the alternatives. Radionuclides that are used in nuclear weapon production and nuclear fuel have half-lives that are thousands of years long. Nuclear waste doesn't need to be stored, it needs to be disposed of in a location where it won't be stumbled on for at least 10,000 years. When designing waste repositories, the single most important concern is water. Water increases the risk of corrosion of the waste packages, water takes contamination from breached packages, and water eventually delivers that contamination to the biosphere. Yucca Mountain averages 7 inches of rainfall a year, and 95% of that runs off and evaporates. The water table at Yucca Mountain is one of the deepest in the world. It is 2,000 feet below the surface. This allows the proposed facility to be both 1,000 feet underground and 1,000 feet above the water table. Additionally, the water table does not run to the ocean. The water table is part of the Great Basin, which runs from the Sierra Nevada mountains in the west to the Colorado Plateau in the east. Water in this system eventually collects in Death Valley, where it evaporates instead of running into the ocean. The waste packages can be loaded in a variety of manners, allowing each one to be loaded for uniform waste heat generation. Package spacing can be varied, allowing each drift to be loaded for uniform waste heat generation. Drifts are spaced to allow channels for groundwater to flow around the drifts rather than through them. The outer shell of the package is made of Hastelloy, a high-nickel stainless steel which is very corrosion resistant. Over the waste packages, a titanium drip shield will be placed. Titanium and Hastelloy have different routes of corrosion, making it unlikely that one set of conditions will cause both to corrode. Now that we've discussed Yucca Mountain, let's talk about some of the alternatives. The storage method currently used, above-ground storage vaults, depends on a high-level civilization such as ours monitoring and maintaining the storage. In the event of a downfall of civilization, this storage method would rapidly degrade. If that happened, the water tables at each of those sites would be contaminated, resulting in untold ecological consequences. Salt beds are a viable alternative. The WIP site, outside Carlsbad, New Mexico, is a low-level transuranic waste repository, which is emplaced in a salt bed. Salt is a relatively plastic rock, which means that once emplaced, the salt would creep over the waste packages, effectively sealing them off from the groundwater. Granite beds are already in use in Europe for repositories. Much of the original research has already been done by the international community. There are also a large number of available granite beds for potential sites. Nuclear transmutation is a wonderful idea in theory. In practice, the process is expensive and also not completely effective. To make it completely effective would require billions of dollars in research and several breakthroughs in physics. To use it as it is would not eliminate the waste and would only reduce it. Fuel reprocessing is used in many areas of the world already. While it does not eliminate waste, it does reduce the amount of waste. Unfortunately, it also increases inventories of weapons-grade materials, leading to nuclear proliferation concerns. Deep borehole technology is in its infancy and does not currently have regulation governing it, or, for that matter, a pilot project to ensure it works as expected. Current studies specifically exclude naval nuclear spent fuel and vitrified nuclear weapons waste. While preparing this presentation, these are the references that I used.